Awesome. Thanks for that, Stephen. So let's swiftly move into a wonderful Q&A. So just to everyone in the audience, if you would like to ask a question, there's a little Q&A icon that you can click and you can drop some questions in there. So, just go ahead and ask a question. And I'm also going to introduce Georgios. He worked for a firm called Paradigm, but he's been working on rollups for about 2 to 3 years. He worked on a protocol called Plasma Cache, and now he also, advises Optimism of their work, and he has some very good blog posts on how Optimism works. So, Georgios, just to introduce yourself, what was Plasma Cache about? Why was that a useful protocol? And what do you think about it now? Is it alive or dead or?
Plasma Cache is definitely a dead protocol. Absolutely. It was the parent, let's say, of rollups. It was a method to do secure transacting off-chain without requiring to do on-chain data availability, simply because the state transition was so simple that you could maintain safety without posting all the data. But this didn't work out for when we wanted to do more complex stuff. So obviously, we've moved on from all of that. A quick intro is that, yes, I work with Paradigm. We're a venture capital firm. We're investors in Starkware and Optimism. I'm also very deep into the layer 2 space and very familiar with Arbitrum's technologies, which, frankly, congratulations for everything so far. This has been quite the journey. So yeah, I'm happy to be here, and let's see if there's interesting questions that we can dig into. Awesome, and also on the Ziki side, I will do my best to fill in Ellie's shoes.
Awesome. So I'll ask the first question, and this is, I guess, there's some historical context to this, but, for rollups, we basically post all the data to the blockchain, and clearly that means the underlying blockchain like Ethereum has high bandwidth requirements, which isn't really ideal. So why not have like a challenge process in there? Why are we posting everything to the blockchain? Does anyone want to cover, like, I don't know, challenge processes and why they're not very useful or good?
Yeah, I can start if so I think actually, and maybe Georgios can speak about this. I think one of the, in my views, one of the key differences between Plasma and rollups was really on this, where Plasma tried to do a lot more in some sense, like take data off chain and the execution off chain, and really, if we imagine that Plasma would have achieved all of its goals and rollups would achieve their goals, Plasma, I think, would have been a much better, would have been better, but because it was really much more ambitious. But I think we sort of realized the difficulties there, and rollups basically said, because you got into all these problems basically about, these mass exits, and basically, rollups basically said, let's punt on one of the hardest problems and put all of the data on chain, and just take the execution off chain. And it turns out, so we're not going to get the 10 or 20 gas transactions that we may have once wanted. We'll get the several low thousand gas transactions, but it turns out that was already a relatively a big win, or at least a good step. I think people today, and you heard Ellie talk about it at the end of his talk, are looking and saying, and maybe we should revisit that, and not really going back to Plasma, but going back to sort of hybrid models of ways to take data off chain and still get some guarantees on chain, assuming that data is available. And actually, if you look back to the Arbitrum paper, our 2018 paper, it was in one of those hybrid models. At the time, again, we didn't think, we tried to build that for a bit. It was clear that people were very much in roll-up phase. They weren't ready for that step, although I think people now are getting ready for that step, because it was clear to us that rollups give us a 90+% benefit over Ethereum. But if the adoption continues the way we think it's going to go, we're going to need to do better than that long term, or at least we're going to need to provide path for people that want better than that. And it shouldn't only be you have your rollups, which are uber secure, and then you have something that's not secure at all. But these middle grounds are really, I think, important places on the design phase, on the design space, in the design space to explore. And that's what this is really all about: just exploring parts of the design space and learning as we do it.
I agree with all that. Another way of saying it is that layer 2 is basically like a compression technique. You take a bunch of off-chain state and you put some on-chain footprint. In Plasma, it was the on-chain footprint was constant, O of 1, just 32 bytes a hash in the happy case. But turns out, the layer 2 community said, evidently we cannot solve this problem for O of 1 complexity. So, what if we just put all the data on chain, which is the current state of rollups? An alternative, or why the data availability is needed, is because when you want to do the fraud proof, you need to be able to reconstruct the state. And if the person that stores the data goes offline and you cannot access the data, you have a problem because you're not able to construct the fraud proof in the optimistic rollups, which means that it's a safety violation. In the ZK rollup case, if you don't have the data, it's a liveness violation because nobody can produce new proofs, because if the operator dies, no new operator can come alive and continue from where the last one left off. So that's why we need data availability. It's an absolute requirement. Techniques which we can use to improve data availability is what Stephen mentioned very briefly in his slides, such as BLS signature compression. In optimistic rollups, because we need to be able to dispute even a simple transaction, we also need to post the transaction signatures on chain. In ZK rollups, because the transaction signature is effectively validated inside the snark, we can skip that part. Another good selling point for ZK rollups has been that you don't need to publish intermediate state roots or intermediate state transitions. For example, an oracle value and the liquidation value. Maybe you don't need to publish the oracle value because the liquidation would not succeed had the oracle value not been valid. So that's one thing. We can use BLS signatures to compress it. We can use data availability committees to compress it with whatever protocol they want to run. We maybe want to use an alternative data availability layer, which is specialized for that. For example, Lazy Ledger, formerly known as Lazy Ledger, now known as Celestia, which is just a dumb data availability chain. Just throw data and you can access it from elsewhere. Or, others have called for Filecoin, or in the future, we will be able to use Ethereum 2 as a data availability layer.
Awesome. Yeah, I think for the ZK Snark one, just to highlight that as well, I always use like high frequency trading as a good example. If you're doing like 1 million trades back and forth on the CMS set, then in the ZK world, you just post the update for those two assets. You don't actually post any information about those intermediary transactions, just the key value updates, or I guess for the optimistic ones, you have to post all the transactions. Okay, well, I think for the next question, Jeremy sort of got to the one I wanted to ask as well. But before I get to that, Denisha's had one question, which was, and I can answer this just to make it quick, how is it determined which Arbitrum block is a block with number 91? What if there's two different blocks with number 91? And I think in Arbitrum, it's the first valid block that gets submitted is the valid one. So it's just based on time that solve the race condition.
You always use the layer 1 chain as the tiebreaker, for canonical ordering.
Yeah, so just to answer that one quickly so it's not left out. This was also about Arbitrum. And I guess, so Jeremy Clark's question is, for Arbitrum, who writes the ARB-OS state back to the EVM, or to Ethereum, sorry? Is it a permissioned operation? And if so, is that a single point of failure? And that's really about censorship resistance, So I'll let you take that away, Stephen.
I'm not sure I understood the question.
So basically, there's a sequencer. Is the like, I guess the way to phrase it is, who's writing the messages or the transactions to Arbor-OS?
Oh, okay, fine. So who's actually posting the transactions on chain? Is that?
Yeah. And is that a permissioned operation? And is that a single point of failure?
Great question. And this is actually an example of how we all the various rollups we affect each other over time. So in the Arbitrum old design, basically this is a completely permissionless operation, and this was done via aggregation. Basically, the idea is that Ethereum has a minimum transaction cost of 21,000 gas, right? Gas and rollup transactions much less than that. So even if this was a permissionless operation, you never, and there's also, by the way, more overhead of posting transactions in Arbitrum, but I'm just trying to give like the lower balance. But even if there wasn't any additional overhead, you never want to post each transaction in Arbitrum as its own Ethereum transaction. It just wouldn't make sense. And this is true for any rollups. You'd always want to, at the very least, batch them. That's a permissionless role. It's just someone taking a lot of data and posting it into what we call the Arbitrum inbox, or the equivalent for another rollup. That's what we actually in early versions of our testnet had, which was this basically permissionless aggregation. Anyone can be an aggregator. all you're doing is taking batches of transactions, posting them on chain. There's no validation happening. The batch transaction will get posted on chain. The on chain here is basically the pool, the mempool, and then they'll be processed in RBOS, and the batch transactions will be discarded. If it's been a bad signature on, or etc., the transactions will be discarded. But some other rollups, and this is, Optimism, for example, had a sequencer early, but also Layer-2s, I think like Starkware has an operator, which has a slightly different role because every operator has to prove. But anyway, the idea is that the idea was with a sequencer is can we give users a better response time and a faster confirmations, right? Because with the way the system I described, you're not getting any faster in layer 1. The way your transaction gets included is it gets included in the layer 1 inbox and gets ordered, like the previous question, whatever the order in the layer 1 inbox, that's the order. So it's not worse than Ethereum, but you're not getting fast response time. So the question is, can we solve all these things? Can we not only solve like the scalability problem, but also solve the confirmation time problem together? And that's where the sequencer model came from. And I'll describe that briefly as it applies to Arbitrum, but I think really this applies, like I said, to really across the board, which is a sequencer is a privileged party, and I'll explain what that means in a second. And it can basically give you fast confirmations that are, and think of these as like zero conf. It's obviously not like the security of Ethereum here, but it gives you some, we'll get into that in a second. It gives you some confirmation. It gives you an immediate receipt of your transaction. And basically what it tells you is, I will include your transaction in this order. So the sequencer gives you what's essentially a promise to include your transaction in a particular order. And then the question is, well, this seems very dangerous. We don't want the sequencer to be able to censor transactions. So we say, no. Okay, so we'll have the sequencer who can give fast confirmations, but we'll also give you the ability to post transactions on chain and put them via any old permissionless aggregator. But if the sequencer is able to give you fast confirmations and say, I will include your transactions on chain, and any aggregator can also post transactions, you have some race condition here, right? How can the sequencer give you a promise? Maybe it's going to get front run by an aggregator, and it will post this transaction in the inbox first, and then you won't be able to make good on the order that it promised you. So to get around this, we basically have a time window in which the sequencer can basically get priority, or in other words, the sequencer can backdate its transactions by a particular window. So when the sequencer gives you a promise, it knows that it will have enough time to post that transaction on chain, and it won't be able to get front run by a different aggregator. So the property that you have, to answer your question, is this permission? It's definitely it's a privileged role in the system, the sequencer, but if all else fails, you can still use an aggregator. So the sequencer can't censor long term. What it can do, though, is it can reorder transactions within short windows. And we, right now in Arbitrum, that's roughly many hours, but we're going to hopefully shrink that over time. It's just a parameter that we get comfortable with the system as you get more comfortable with the system. But that's basically, the sequencer does have that privilege. It can't censor, but it can reorder. That's, of course, very dangerous to be able to reorder, because then you can extract MEV, or minor extractable value. And that's why, this is true for us, but also we run the sequencer and we don't do any reordering. And I think for Optimism, it's the same. They're running their sequencer and they won't do reordering. But over time, we plan to decentralize it. And this is what I alluded to at the end of my talk. The way to decentralize a sequencer, at least the way we believe decentralized sequencer, is this paper I co-authored at Cornell with Ari Jules and Himna Kalkar, which is basically a fair ordering BFT. So you have a consensus protocol that guarantees fair ordering, and you distribute the sequencer by a bunch of nodes. And as long as the honesty property happens, as long as the honesty property holds, the BFT gives you a guarantee that not only do they reach agreement, they also reach agreement on a fair ordering. And this is actually a new property in BFT. Every other previous protocol only cared about agreement, but had no notion of fairness. So if all the nodes agreed to include the transactions in the exact reverse order that they were included, every other old consensus protocol would have been happy. But this is something new that we're studying. The work that we did was really early work. There's been a lot of work since, and I think we're not still at the phase yet where we have something that's ready to be implemented, but there's a lot of interesting work going on there that we're involved with.
Awesome, great. Well, I'm gonna point this question at Georgios. So this is another question by Denise's. This is funny because he's actually on the panel right now, so he can just ask it, but I'll read it anyway. And it's really about the 7-day dispute period. So the issue with 7 days is that it's a fixed number, 7 days. Is there some way to make that dynamic somehow based on the network congestion? You know, if the network's congested, could we reduce that number, or should we always keep it at some fixed value like 7? So,
yeah, of course. So the 7-day dispute period is a security parameter. The longer it is, the more time you have to dispute something. So plausibly, the probability that somebody actually appears and challenges a fraudulent state update, it approaches to 1, the larger your dispute period. Too short a dispute period, and you may have an insecure protocol. Too long, and you have a protocol with very bad user experience, because the time to withdraw from layer 1 or to transfer a message, to be more accurate, from layer 2 to layer 1 is always lower bound by that latency. If you wanted to bypass that latency, you would need to introduce some form of market maker that kind of bypasses that and fronts you the money on the layer 1 chain or on the other layer 2 chain. And these kinds of solutions already exist. But basically, the longer the time that you need to wait, the higher the price you will need to pay to the market maker. So it's a very good question to think, can we make that dynamic? Because surely there can't be one correct value. And the way that we would do that today on Ethereum is that with the activation of EIP 1559, and we have Tim on our group who can also give us more context onto that, with the introduction of EIP 1559, an opcode was added to Ethereum called base fee. And the base fee opcode, when you query it, it returns you the current value of the base fee. And the base fee can be used as a proxy for on-chain congestion, because it reacts to transaction demand and to how full the blocks are. So in your fraud-proof protocol, you could say, you know, instead of hard coding and 7-day parameter, take a moving average of the last whatever days worth of base fee and adjust your dispute period based on that. And Tim, correct me if I'm wrong.
No, Georgios, you said it well.
Stephen, do you want to comment on it as well, or?
I think I mean, if you have an arbitrum specific question, I'm happy to, but I think Georgios said it quite well.
Awesome. Okay, cool. So
there was also a paper by one of the no-cost co-authors that showed, I haven't read the paper, so I don't know if it works or not. But I remember that the paper describes a way to do it without 1559. Probably more expensive because base fee is in the protocol, whereas you'd need to do it in an auxiliary way.
Yeah. Just a follow-up question for Stephen, I guess, on this is, does Arbitrum plan to make these fees, dispute periods dynamic? Is there any plans for that, and what are these?
So let me actually talk, and I guess I'll dig in a little bit to how Arbitrum differs. So in a system like Optimism, where you again where it's, at least as it exists now, it's the 7 days is really 7 days. It's really a fixed period, because there's no interaction involved. Right? A fraud proof is really just a single step. In a system like Arbitrum with interactive proving, 7 days is not exactly really exactly 7 days, because there could be multiple rounds, and this is, you know, there's sort of there are ways to delay the system. We have exponential costs of delay in our protocol, so the cost to delay significantly will rise. But right now, so it's 7 days is the happy case. Will be no lower than 7 days, because we give you at least 7 days. It will probably be not much longer than 7 days, but the cost to get it to say, you know, to 14 days is, you know, it's possible. Getting it past that, we get, you know, it will get prohibitively expensive for someone to do. In terms of yeah, there's also another question, which is 7 days really the right number? To be honest, I know that the community has basically formed around 7 days, and it's not my battle to fight, and you know, it's not one that I want to fight. This is ultimately about community comfort and people being comfortable putting their funds in the system. So if that's what the community consensus is, then I'm glad to support that, and that's why, you know, we've chosen that. You know, that came consultation with Vitalik and others who felt, you know, very strongly about this. I personally think that, nevertheless, that disclaimer being said, I personally think 7 days is a bit long, and I'll tell you why. If you can imagine that transactions can be censored on Ethereum for longer than 7 days, we'd have lots of really, really big problems. Like if you couldn't get an Oracle update onto Ethereum for 7 days, or you can manipulate Oracle updates with that long of a window, you'd have like much of DeFi would be broken in very large ways that requires some synchronous assumptions. So and this is, by the way, a similar so you know, that's, I personally think that you know, again, and this is almost like we're securing a bathroom door with a high security lock, that you know, we're giving this very strong assumption here, but actually the system breaks in other ways if this assumption isn't held elsewhere. But in terms of interactive periods and doing this dynamically more than what happens because of the interactive fraud proofs, we don't have any immediate plans, but you know, definitely something which our research team is looking at.
Awesome. So there's one last question. We only have a few minutes left, so I'll point it to Georgios first, and I'll hopefully point over to you, Stephen. And it's again from Jeremy Clark, and it's really asking. The question he asked earlier, he didn't feel like he got the full answer that he wanted, and the specific question was, you know, a transaction that's writing L2 state. So basically, a transaction going from L2 to L1. Once all the disputes are resolved, you know, how is that processed? You know, is that permissioned, or, you know, is that a single point of failure? So it's basically, you know, once you confirm a commitment, what about the side effect? You know, let's say it's withdrawal. You know, how does that get processed? So I'll let Georgios jump in first, and then Stephen, you can take it afterwards.
Yeah, so traditionally, the architecture that we've seen so far in both Optimism and Arbitrum is that they define a contract that Arbitrum calls the inbox, Optimism calls that the cross-chain messenger. And anytime you do a L2 to L1 transaction, it's not really that you need to play the dispute game for the transaction, but rather that the relayer, that the smart contract on layer 1 says that any transaction that's older than 5 days can be processed, or 7 days. And to the point around disputes, the disputes are played on chain and can be triggered by anyone. So it's not a single point of failure or a permissioned procedure. Anybody can submit a dispute for any targeted piece of state. And typically what happens is that, let's say, a disputed transaction 4 to 5 or block 4 to 5 or whatever the mechanism says, if a fraud proof is successful from block 4 to 5, and let's say then after there's block 6, 7, 8, 9, all the blocks or transactions after the one being disputed are discarded, which is why you need to enforce on your messenger, on your layer, on your messenger contract or your inbox, that messages need to be old enough such that they cannot be pruned from the on-chain canonical state.
Stephen, do you want to add to that, or just
no? That was great. Nothing to add to that. Once again.
Awesome, great. So I think this is where we'll end this panel. So thank you very much, Stephen and Georgios, for joining us. I'm sure if some students email you with questions, I'm sure you have time to answer it. So
I'll drop my email also in the chat.
Awesome.
I will do that as well. Yeah, thank you for having us.
Awesome. Cheers, guys. And we're going to move on to the next.